Afternoon, everyone. Thanks for coming along to talk. So yes, what I want to talk today about is basically about the success of Docker and Kubernetes. So over the last 10 years, they've gone from being relatively niche technologies to being pretty much everywhere. And I want to talk a bit about why. What was the factors in their success? What caused their success to occur? Some of the things I think...
You need to come closer to the mic,
Oh, I'm
please.
close to the mic, right in. Some of the things that didn't matter, and also what that might mean for other open source projects. Now, one thing I want to mention early on is that not everyone in open source is going to want their project to be some huge successful thing. Personally, I write open source because it solves some of my problems, and I put it out there in case it helps someone else's. But with that said, we've heard quite a few times at the project that a lot of projects do want to become big. They do want to become big parts of an ecosystem, maybe have companies formed around them. And that's kind of where this talk is going from. So anyway, I should have. First thing about me, why am I giving this talk? So I'm a senior security researcher and advocate at Datadog. If you haven't heard of Datadog, we're a large open source, we have open source, lots of open source, observability and security company. But I've been involved in open source for a long time, over 25 years at this point. I've been a user of open source for a long time. I have also been involved in various open source projects. So I was an OWASP, which is the Open Web Application Security Project, chapter leader for a number of years. These days I work in the Kubernetes project, helping out with things like SIG security. And one thing I would mention about this is all basically opinions I've formed over a period of time. So as a result, they're all my personal opinions. These don't, especially the more controversial ones, represent necessarily the opinions of any employer, past, present, or future. Just get that one in there, in case anyone says Datadog says X somewhere down the line. No, Rory says X. So, first, are they successful? Right? I'm coming up here with the proposition that containers have been successful, but can I substantiate that? I first encountered containers and thought these are going to be popular quite a long time ago. It was 2013, I was doing security architecture reviews for companies. And I was a medical startup. And I saw, in place of where I've expected to see VMs, I saw Docker and containers. And that was interesting to me because it was pre-Docker 1.0 and people were already using it. And that was the first thing that gave me the idea, hey, there's going to be something to this, because otherwise people wouldn't be using this pre-1.0 software to run their business. Kubernetes was similar. I started hearing about that in 2016, when, again, people started asking for security reviews of Kubernetes clusters. That was quite early for Kubernetes. And one of the things that surprised me was the companies coming to us and asking were big organizations. The very first time I was asked was central government here in London, and they wanted reviews of clusters in 2016. So again, that seemed like this is going to be popular. But these are just my personal anecdotes. These obviously don't, there's no kind of actual data behind that. So what could we find that actually says, how do you measure success? So one way of measuring success is you can look at the users, right? Who uses this software, and does a large proportion of the people who could use it, right? So Docker, the primary user group is developers. Docker was designed as a developer tool for developers to run containers. And this is from the Stack Overflow survey last year. Stack Overflow, obviously a very large site that a lot of programmers use, a lot of developers use. And they asked, what technology do you use? And in the other category, Docker is number one. Okay, I think that's fair to say that's success, right? You're the number one tool amongst the user group that is trying to use your software. Kubernetes is in the list as well. It's slightly further down, which I think is because Kubernetes user group is not just developers, it's a lot of other groups as well. But Docker being number one, okay, that's one indication of success. Another indication of success could be GitHub stars. Now, depending on who you talk to, some people have a bit of a debatable point. Is GitHub stars really a good measure? Some organizations like it, some don't. There have been some cases of people gaming the stat. But if we look here, we can see it's over a very large number of years. Both of these projects have got a very large number of stars. Docker is Moby for historical reasons, and Kubernetes is there as well with over 100,000. So if you want to use that metric, we can say these container things are successful because look at all the stars. The last one might be, will people come to conferences? Will they pay money to listen to people talk about this technology? This is the keynote at KubeCon EU last year in Paris. There were, I think, 13 or 14,000 people at KubeCon last year. So we can say by that metric as well, Kubernetes is a pretty successful piece of software because 13,000 people turned up to hear about it. So by all of those metrics, we can say, yes, they're successful, right? There's other things we could try and use to measure them. You could look at things like code velocity. You could look at how many developers are involved. But by those metrics, these are successful projects. And so that leads us to the main point of this, which is why? Why did they succeed when lots of other projects who tried to do similar things didn't have as much success? And That's what we want to talk about next. Why were these things successful? Why did these projects specifically get traction? People liked them, people really used them. And here's a set of things that I think, anyway, from all of my involvement in these communities, I think these are relevant. First one, solving a real problem. If you've got an open source project, people will come across your project, they'll come across it on blogs, they'll come across it on social media, and they'll come to your homepage, and they'll be thinking, what problem does this solve? Does this solve a problem I have? Because that's why people use software, right, to solve their problems, to get things working. So you want to be able to say, my open source project solves a real problem. Docker has this one nailed, because the problem it tries to address is, well, it worked for me on my computer. If you're a developer, you write code, and then you want other people to run it. You put it into a production server. You put it on GitHub and have someone download it. You sell it. And a lot of times, ever since I've been involved in IT anyway, one of the problems is that you give it to someone else, it doesn't work on their computer. It doesn't run. And that's bad. And Docker attempts to, and in a large number of cases does, solve that problem. So that's a very easy to describe problem. It's very easy to explain to someone what Docker does and why you would want to do that. Kubernetes, similarly, you want to run containers on a lot of computers. You don't just want to run one, you want to run it on 100, 1,000, 10,000. Well, at that point, you don't want to have to go to each machine and manually start the container. You want something to do it for you. And whilst Kubernetes does do a lot of things, and anyone who's involved in Kubernetes knows it does a lot of things, that's its core prospect. And again, you can explain it simply. So it solves a real problem. And that's the first thing I think was a reason for their success. But one other aspect of this, which I think is important, is it solves a real problem that lots of people have got. If your project has a maximum number of people who have that problem of 100, that's your user base. Your user base is 100, maximum. So if you ever want to have tens of thousands of users, this is not a good problem to focus on because that many people can't have that problem. So solving a real problem, I think, is really important, and being able to have something you can say, this is what my project does. Easily explain it. Next one, fast time to value. Someone comes to your project. They come to a website, they come to a GitHub page, a GitLab page, wherever you might be hosting your project. How fast can they get from seeing your homepage to being able to see that you can solve the problem they've got? The faster it is, the more likely they are to stick around and continue to use your product. We look at Docker. You can do Docker run one of 10,000 different images, and you can be up and running with some kind of application server in a matter of minutes. That's a very fast time to value. You can go, okay, this solves my problem. I can run my application this way. Kubernetes maybe isn't quite as simple because it's a different type of product, but you can get up and running with a cluster fairly quickly these days. And we've seen this is not just in containerization. If you look at projects like WordPress, if you look at projects like Ruby on Rails, which have been very successful, their pitch was, you can get going with us in 10 minutes. You can have a blog in 10 minutes. You can have a website in 10 minutes. Having that fast time for users to say, yep, this solves my problem, is, I think, hugely important in actually getting and retaining users. There is actually another aspect, I think, to Docker specifically, which is one of the things about getting fast time to value with Docker was you didn't have to change the way your application worked to make it work. So there's lots of people try to solve the application packaging problem. And sometimes they might say, well, you have to recompile the app, or you have to use our libraries, or don't use specific libraries because they won't work in this environment. And Docker doesn't have any of that. You can take most Linux apps, put them into a container, and have them running. That's hugely valuable because people go, I don't want to rewrite my app to make this change in how it runs. So fast time to value in both cases of that, I think, is very important. Next one, open source foundations. I wouldn't be standing at State of Open and wanting to talk about these projects without focusing on the idea that they are based on open source technologies. So if you look at Docker and how it runs applications, they didn't rewrite all of those aspects of the sandbox. They didn't create a new application sandbox. They looked at Linux and said, hey, Linux does all of these things already. You can isolate applications in a number of ways. Let's just reuse that. Let's not bother rewriting everything. Let's reuse what's already there. They reused Linux technology. And that would enable them to move very quickly because they didn't have to spend all their time writing something themselves. Instead, they just took what was there, and then they could focus on other parts of the problem. Kubernetes is similar, right? So Kubernetes has a fancy software-defined network. Right? It's one of its main features. It's actually basically IP tables, which is a venerable part of Linux that's been there for over 20 years. Instead of rewriting their own one, which they could have totally done, and people have subsequently done now, Kubernetes is popular, but in the early days they didn't do that. They just said, well, let's just use what's there. And they used IP tables. So basing their technology on existing open source foundations was massively important in them becoming successful because they meant they could focus on other things that mattered to their users instead of writing on low-lying code that they would take a long time to write from scratch. but in addition to open source foundations, also open source foundations. So different meaning of the word. When your project becomes successful, if you are lucky enough to have a successful project, the questions will start to come of who manages it and who's running it and what is their direction. And we've seen this at the conference today and yesterday. We've seen Meet the Forkers as a concept of projects have been forked because the original company that came up with the idea have changed direction. They've said, hey, we're going to license this differently. One of the things that is very important is actually saying, no, this is part of an open source foundation. We can see that really clearly in containerization. So in Docker land, Runc is managed by the Open Container Initiative. Containerd, which is another key part of Docker, is managed by the CNCF. So if you're working with those projects, you have confidence that they are managed by an open source foundation and you don't have to worry about them being forked or changed because they're open source. Kubernetes obviously is completely managed by CNCF. So Cloud Native Computing Foundation manages it. Therefore, you have confidence in that. So open source foundations, I think, are very important in managing and ensuring things are right. Now, I allowed myself one AI image in this entire deck, which is this one. This actually comes to a very brief aside, which is when I came up with this, sometimes you come up with talks. You come up with the title first, and then you work out the talk later. And I came up with this, the title, Containers Rule Everything Around Me. And I thought someone will have written a talk called that before. And I dig around on the internet, and I found one which is about physical shipping containers, nothing about software containers at all. And then I was like, how can that not have been used as a title? I asked some people and talked to them about the talk, and then realized almost no one got the reference. It was like 90% of people. Has anyone heard of a song called Cash Rules Everything Around Me? See? If you know the song, it's a really great reference, but no one knows the song. Okay, there's a song called Cash Rules Everything Around Me by the Wu-Tang Clan, and that's where I got this idea for the title of this talk. But as you can see, it doesn't always work out the way you expect. The reason I wanted to have that up, though, is because we have to talk about money. Money is a bit of a dirty word in open source, or can be, but if you are trying to get adoption from companies, right? You want companies to use your open source project. Companies care about money. They care about how will this make me more money or how will this save me money. And if you can articulate one of those two things, you will help get adoption from companies and you will help people who want to put your project into companies, because when they're saying to their management why they should spend time on this, they can say, hey boss, let me work on this thing because it will save you money. Docker has a really easy story here. I want to, in the old world you might have said, well, I've got physical servers, and I've got a set of physical servers we do development on and test and everything else. And with Docker, I've got all the containers on my laptop. Instead of spinning up a whole lot of physical servers, I can do it on one laptop. Awesome, I've saved money. Kubernetes is even easier. Kubernetes' story is you used to have 100 physical servers or 100 virtual machines, each of them running one application. Now, we can run 5 applications on each server because they weren't fully utilized before. Great, I've just saved you a whole lot of money off your server bill. So in both cases, having that idea of saying, I can save you money, I think made adoption a lot easier. I mean, I've been to loads of businesses who adopted Kubernetes, and a lot of it wasn't because of the cool, shiny tech, it was because someone said, hey, you can save money. Not a surprise, really, because businesses like saving money. There is actually, though, a different part of money to the container story, and it's one we see in other parts as well, which is Docker Hub. Now, I'm sure if you've used containers, you have used Docker Hub, inevitably. The good thing about Docker Hub is it's free. It's free as a user. So I have got a container image on Docker Hub. It has 1 million downloads. I have no idea who downloaded it. I've downloaded it maybe 200, 300 times. The rest of them, don't know. Someone really likes my container image. But I have never paid for that. I have never paid any money for the network bandwidth. I have never paid for the storage, and I have never paid for the commute. If I had to pay for it, I would not have uploaded this image to Docker Hub because I don't know who's using it, and they're not paying me any money. The fact that Docker Hub is free is a huge part of its adoption, because it removed all of the friction of where do I store all the files I want people to download. Now, there is obviously a long-term sustainability question of at some point someone's going to have to pay the bill because Amazon don't give you huge amounts of network bandwidth for free, or whoever it is they host Docker Hub these days. But it is very valuable in getting adoption. And we can see it again in the AI space. So Hugging Face has already been mentioned a couple of times in talks today. Hugging Face, if you don't know it, stores models. Model files are massive, bigger than most container images by a decent margin. I can go to Hugging Face, I can upload a model, someone else can download it, and neither of us pay any money to Hugging Face. Great. Great for adoption. Again, I'm not sure who's paying their bandwidth bill. But money is relevant, much as we might not want it to be. So standardization is another important aspect of all of this. And I think with standardization, you see it when you get more adoption. So when lots of people use your project, they want to have a say in it. And they want to say, well, you know what, I really like your project, but I kind of wish it did this, or I kind of wish it did that. And they want some place where they can go and actually make that knowledge, make that desire felt, and actually maybe affect change in the direction of the project. Because if you get popular, people will come along. And you'll see container ecosystem is a good example of this. All of the major tech players are involved in the container ecosystem. They all want to have some way of influencing the direction of it. And standardization is how they've done that. So in Docker, the main specs, the registry spec, the image spec, and the runtime spec are all standards. They're OCI standards. So you can develop to those standards confident in the knowledge that your tool will work with all the other tools in that ecosystem. In Kubernetes, everything is managed by the SIGs, and they have got standards for various things like runtime again, networking, storage. If you want to develop to those standards, you can and have confidence it will work. So if your project gets really big, standards start to become important. So these are some of the things I think that were successful, some of the reasons why I think it's been so successful. But there are some things that I think, anyway, didn't matter. And there are things that you think maybe should have mattered, or things you think maybe people would have wanted to do this. First one is early standardization. Be careful with standardization. Be careful with standards. Do not dive into the world of standards and think, I want to make my project a standard too quickly. Because standardization has consequences. It slows things down. If anyone's ever been involved in a standards body at all, you will know what I mean by this. I once was involved in a standard, it was a container security standard as it happens, and it took us a year of weekly meetings to make one document. No word of a lie. So you want to get one document out, it could take you a year. If you are a young project, you're trying to develop, you're trying to expand into the space of what you want to do, you do not want to be having a year's worth of meetings to decide a single document. So standards are important, and I think it's a good idea to do them once you are successful. You don't do that when you're young, when you're trying to become successful, because I think that's not where you want to spend your time. It's very time consuming, and it's going to, slow you down quite a bit. So be careful with standardization, definitely. This one is the one that gets me into trouble because I'm a security person. I've been in security for 25 years, and I'm about to tell you not to worry about security. What do I mean by that, and how am I going to justify that statement? So earlier on, I said that Docker made use of existing Linux technology to create its application sandbox. The Linux technology it used is not a perfect fit for a sandbox. There are other sandboxes available which provide a better security, level of security than what Docker provides. Virtual machines, which came before Docker, provide a better level of isolation for applications than Docker provides. But instead of spending their time creating a perfect security sandbox, Docker didn't do that. They took existing technologies, tweaked them as much as they could, and ran with it, which allowed them to spend all of their time working on other things that their users wanted them to do. And did that hurt their adoption? I'm going to suggest from what we saw earlier, it did not hurt their adoption. Kubernetes has a similar story. In the early days of Kubernetes, I was a pen tester, and I used to pen test clusters, so I used to attack clusters and try and break in. We pretty much always got in less than half a day, every single time, because Kubernetes in the early days was horrifically insecure. Until version 1.6 of Kubernetes, it was basically distributed remote command execution as a service with no authentication. Literally. This did not damage their adoption. Even to this day, there are, I think, 4 unpatchable CVEs and at least 1 high unfixed issue from a Kubernetes audit that's been there for about 10 years now, and it has not damaged their adoption. They're adopted by governments, they're adopted by major corporations, they're adopted by anyone you can think of, and they're put into all sorts of sensitive places. So I'm not telling you not to spend time on security if you're successful. I'm definitely not telling you that, for the record. But I am saying, in the early days, that maybe isn't where you want to focus your time. Maybe you want to focus on finding out who your users are, working out how to solve their problems, and working out how to solve their problems quickly, rather than focusing on creating some super cool, hardened environment. So that's my pitch for don't spend time on security. So the other thing ties into that. Fancy architectures. As an IT person, as a technical person, it's very easy to think, oh, I've got this great idea, I can create this really cool architecture, and I can do all the bits myself, and I can hand code everything. I'm going to say don't do that, because you're still working out what your users want and how they want you to do it. Don't spend a lot of time up front creating some amazingly fancy, cool architecture. Again, look at the example of containerization. They reused existing things that were there. They weren't necessarily a perfect fit for them, but by reusing them, it enabled them to move very quickly and enabled them to focus on other problems. Creating a fancy architecture in the early days is probably not where you want to spend your time. So, what does it mean for other projects? What are the lessons you can take from this? What could you do when you go back and look at your own open source projects if you're looking to become major part of an ecosystem, maybe even start a new ecosystem? Focus on user problems. That's my main thing. Work out who your users are. Are your users developers? Are they IT people? Are they security people? Are they perhaps in a different field altogether? Knowing what problem you're solving, so being able to say, the problem I'm solving for my group of users is this thing, is probably the most important thing, because that's how you pitch your project to people. And working on that fast time to value. The faster they can see it solving their problem, the more likely they are to stick around and actually use your project and not just, let's be honest, click to the next tab in their browser where they've got another project that might look at the same thing. And this is one where, I mean, definitely I'm sure everyone here will have been to GitHub pages and you read down the README and you're like, I have no idea where to get started. It's a cool sounding thing, but I can't see from the first page I get to how I get started with your project. And you probably click on the next tab and go and look at something else, because there's lots of projects out there. The right kind of documentation matters. Documentation in general isn't always the first thing people think of when they think of open source projects. But I will say that the right kind of documentation matters, and it feeds into what I was talking about before. I think the humble Quick Start Guide is the most important document you will write. The Quick Start Guide is what people use to try and get started. And if it works for them and it gets them going quickly, ironically, you could probably use containers for that. I mean, a lot of people do, and it works really well, because you can just do a quick, hey, run this container image, and you can get started on it, and it all works. So I think the right kind of documentation matters. And the last bit of advice I would give people is don't prematurely scale. Don't think I'm a huge project with, GitHub, 10,000 stars on GitHub before you actually have to. Because a lot of the problems that the big projects handle, things like governance, things like, scaling, you don't have those yet. You want to focus on the immediate issue. Don't think about standardization. Don't think about committees. Think about coding, coming up with solutions to problems, and worry about the scaling thing when you get to the point where you've got lots of people. So that was the talk. I hope that was interesting. I mean, I think containers is an interesting use case because containers have been so successful, but I think also we can learn a lot of things from why they were successful. And hopefully this has given people some ideas they can use in their own projects. These are all my socials. If anyone has any opinions, wants to say Rory has no idea what he's talking about, or Rory does know what he's talking about, free to hit me up on one of those. I'm always happy to have a chat. Thanks.